In this video, we're going to discuss how to calculate sample size when estimating population proportions. Okay, so what's going on here is a situation where we want to collect data to estimate a population proportion, and we want to know how many people we should sample in order to have a certain confidence level and a certain margin of error. Okay, so specific width of a confidence interval, which is what basically margin of error is. Okay, so let's go ahead and write down the equation for this. So first we know the equation for the margin of error, right? This equation, z alpha divided by 2 is critical value times the square root of p hat q hat divided by n, right? So we can use some algebra and solve for n. Okay, so this is the margin of error equation, but we can solve for, well, say we were given a margin of error and we want to know what sample size we should need. Well, we could solve this equation for n. All right, so for example, the first thing you would do is divide both sides by the critical value. All right, and then square both sides. So that square root goes away. So go ahead and square both sides. So then you have e squared over z alpha divided by 2 squared. Go ahead and divide both sides by p hat and q hat, so that equals 1 over n. Lastly, take the reciprocal of both sides. So then we have n equals z alpha divided by 2 squared times p hat q hat divided by e squared. Okay, so just a few algebra steps in order to get from one equation to the next. Okay, so these two equations are exactly the same. It's just one is solved for e and one is solved for n. All right, so this is the equation that we can use in order to determine the sample size given a particular confidence level. Okay, so a particular confidence level would be given the critical value here and given a particular margin of error. And also we will need to know some estimates of the sample proportion, some estimates of what the sample proportion may be. All right, so let's go ahead and use this equation and answer this first question here. Okay, so a campaign wants to estimate the proportion of Americans that support their candidate within 3 percentage points. Right, so within 3 percentage points. So that means the margin of error should be 0.03, right? 3 percentage points with a 95% confidence. That's telling us something about what z alpha divided by 2 is, what the critical value will be, right? Prior studies showed that 65% of Americans supported their candidate. All right, so that's the prior estimate of what p hat is. How many individuals should they sample to estimate the proportion of American support, right? So let's go ahead and write down the equation. N equals z alpha divided by 2 squared p hat q hat divided by e squared. All right, so in this question, they told us that the margin of error should be 0.03. They want to be within 3 percentage points. So that's within 0.03 in terms of a proportion. Okay. And then 99% confidence. So when I'm calculating z alpha divided by 2, I'm going to go ahead and draw this over here. So here's z alpha divided by 2. Here's the negative version of z alpha divided by 2. And 0.99 is in the center. So that means 0.01 is left over for each tail. 0.01 divided by 2 is 0.005. 005. Okay, so total area under the curve is 1. And we're trying to look up in our table to figure out the area behind this critical value. It'll be 0.99 plus 0.005. Which is 0.995. Okay, so let's go ahead and look up that z value. 0.995 is the area. Okay, so here we go, 0.9949, 0.9951. So that's directly between 2.57 and 2.58. Okay, so we'll go ahead and use 2.575, which is the number that's directly between 2.57 and 2.58. Right? So Z is 2.575. All right. P hat. They gave us prior studies show that 65% support their candidate. So then P hat would be 0.65. Right. So Q hat is 1 minus P hat. So 1 minus 0.65, which would be 0.35. All right. And let's see, what else? Oh, yep, that's everything. We have everything that we need to calculate the sample size. So let's go ahead and do that. So 2.575 squared times 0.65 times 0.35, all of this divided by 0.03 squared. All right, let's pull out our calculator and do this. So 2.575, square it, okay, times 0.65 times 0.35 divided by 0.03 squared. All right. So here we go. We get our answer, 1,667.07. Okay, so let me go ahead and write that down. 1676. So 1676.07. Right? We should always round estimates of sample size up. Okay, even though it's a very small 0.07, we need to still round it up because we can't have 0.07 of a person. We don't want to say how many people you need in order to have the appropriate confidence interval. So we should always round n up. So our final answer is going to be that they should sample 1,677 individuals in order to obtain a confidence interval within 3 percentage points with 99% confidence. All right, let's do one more example. In this example, this is very similar. The only thing that's different about this example is that they don't give us the proportion. So in this one, they said prior studies show that 65% of Americans support their candidate. This example does not give any information about prior studies, right? So let's go ahead and read this example. A campaign wants to estimate the proportion of Americans that support their candidate within 3 percentage points within 98% confidence. This confidence interval is slightly different. Find how many individuals should they sample to estimate the proportion of American support. Okay, so let's go ahead and write down our equation. C alpha divided by 2 squared, P hat, Q hat, divided by E squared. Right? So in this example, they don't give us an estimate of P hat. Right? That's the main difference between this example and the example we just did. So what are we going to do? Right? So in the situation where they do not give you an estimate of P hat, so this is a rule, all right? So when no estimate of P hat is available, right? So when no estimate of P hat is available, set P hat equal to 0.5. So the reason why we do this is because this will provide a sample size n that will be the largest possible sample size given a particular confidence interval and a particular margin of error. All right. Okay, so let's go ahead and calculate this example. So first, E is still within 3 percentage points, so 0.03. Z alpha divided by 2. I'm going to go ahead and do this over here. All right, so I have 0.98 in the center, Z alpha divided by 2 over here, negative version over here, 0 in the center. Okay, so how much area do I have in each tail? I would have to have 0.01 in each tail. right, which is 0.02 divided by 2. Right, so the area that's behind this z value is all of this area. So that'd be 0.98 plus 0.01, which is 0.99. All right, so let's look up 0.99 in our table. 0.99, let's see. 0.99, okay, so there it is, between these two numbers. So 0.9901 and 0.9898, so 0.9898. Well, it's closer to 0.9901, right? So we will go ahead and choose the z value that corresponds to 0.9901. So that's 2.33. Right? So z alpha divided by 2 is 2.33. Right, so now we're ready to go ahead and calculate n. So it's going to be 2.33 squared times 0.5. Now, if p hat is 0.5, so is q hat. Right, 1 minus 0.5 is 0.5. Okay, divided by e, which is 0.03 squared. So go ahead and pull out your calculator. So 2.33 squared times 0.5. Basically, 0.5 is being squared. 0.5 times 0.5. Okay, divided by 0.03 squared. So we get is 1508.03. Okay, so 1508.03, which we always round up. So that'd be 1509. So 1,509. That's how many people they would have to sample in order to get a 98% confidence interval with a margin of error of 0.03.